Thanks for the privilege and welcome again to our next class as we continue with our mathematical series. Here in this class today we're going to introduce logarithms. 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 Now, in our previous class, if you can remember, we have talked about indices where we try to write a number in terms of the power of. A number in terms of the power of. Let's consider giving that A, B, and C are any real numbers. Any real numbers, of which we have also known what real numbers are. Now, in case we have A, B, and C to be any real number, we can write a number as A being equal to B raised to power C, of which where B is greater than 1. Now, in this case, in our indices, where this is indices, we are trying to write a number in terms of the power of something. Now, in this case here, now you can see that we are saying that this number, given that this is a number, we can write this in terms of a number raised to a particular number. Now, this expression in indices, we can also write in another way called logarithms. Like example of this kind of thing, let me say 9 being equal to 3 raised to power 2. You can see that this is a number, but we have tried to rewrite it in terms of indices. A number where this is the base and this is the power raised to the power of something. Now, we are saying that this expression that we have learned in indices, we can also rewrite it in terms of logarithms. Now, if we want to do that, we say this power here, which is C is the logarithm, of the number A, say A, to base B. C is the logarithm of the number A to base B, or that is in base B. How do we mean by that? This we can write, this statement we can write as C is equal to the logarithm base B of the number A. So invariably, this expression that we have in terms of indices, we can also write it in terms of logarithm. So in other words, this expression here is the same thing as this expression that we have indicated here. So if we want to rewrite this as this, then we are indirectly saying, if you look at this, you can see that the C here, in this case, is looking like the 2. It's in the place of the 2, where the B is in the place of the 3, and 9 is the number, which is the A. So we can write this expression here again as 2, which is the logarithm of the number 9 in base 3. We are saying that this expression is the same thing as 9 is equal to 3 raised to power 2. Equal to 3 raised to power 2. Now, let's consider another expression, say 25, which we can write as 5 raised to power 2. Now, from the expression that we have here, you can see that our 25 is the A, our 5 is the B, where the 2 is the C. We can write this expression indices in terms of logarithm. This, if we want to do that, we say 2, which is the logarithm, 2, which is the logarithm of the number 25 in base 5. So these two expressions, if you are not comfortable with this, you can use this. If you are not comfortable with this, you can also write this in terms of indices. Now, in our WAEC and other junior exams, all these things, we do see them in our objectives as some objective questions, where sometimes we will be asked to determine this value, sometimes we will be asked to determine the power or the base. Example, we can sometimes consider things like, just say 1, we say 4 is equal to x 81. You can see this kind of expression where you will be asked to determine the value of x. Sometimes 2, you can also have say x is equal to the logarithm of 16 base 2. Now, we can also consider the power. We can also consider the power, assuming the power is not known, where we can write 2 is equal to the log of, in base 7, of log of the number x. Now, in this case, in these various examples that we have indicated, if you can see, in this first one, the base is not given, it's not known. You are asked to determine it, which you can do. In this case, the the power itself is not given, which you can also determine. The number and the base are given. Like in the third case here, the power is given, the base is given, but the number itself is not given. So irrespective of the case, if and only if we are comfortable with this other expression as we have here, we can always do business with all this. Now let's try to see them before we go ahead determining the laws, some laws of logarithm, which are of great importance to us. Like in this first case here now, we have an expression 4 is equal to the log in base x of the number 1. But remember that we have learned that coming to this one, we have that if we want to rewrite this is the number that we have. So we say 81 is equal to the number that is the base raised to the power, which is 4. So this expression, as we used to have here, if you look at it, this thing and this thing, this one is looking like this expression, whereas this other case is looking like the question that we have. Now, in this is simple, as we have also looked at, considered when we were considering indices. Now that we have this kind of expression, we just try to see if we can rewrite this our left-hand side in terms of this raised to power 4. Anything, a number raised to power 4, so that we can equate the two sides. In doing that, what number do you think we can multiply 4 times that will give us 81? What is that number that we can multiply 4 times itself? So let's try to also write this in terms of indices, a number raised to the power of something. Now if you want to do that, that number is 3. 3 times 3 is 9, times 3, 27 times 3 is 81, which is into 4 places, 3 times 3 times 3 times 3, which we have, that is 3 times 3 times 3 times 3. But in this is said, when you have this, you don't need to write this long expression. Rather, you just write it as 3 raised to power 4. 1, 2, 3, 4. So this we have here, which is equal to x raised to power 4. X raised to power 4. Now, if you look at this expression, you can see that the powers here are the same. So you can take off those powers. Then if you do that, you have, or you say divide through by 1/4 on both sides. If you do that, these ones are off, and you will be left with 3 equal to x. 3 equal to x. So our x from the beginning here is 3. Our x here is 3. So this thing that we have been looking for is just simply 3. Our x is equal to 3. So if the base is not known, this is how you go about it. Then you can get the base as simple as ABC. The next one we want to consider is that of 2, where the power from this expression, from the earlier expression that we had, the power is not given. The power is not given. You can see the power, that is what we have, which you said is the logarithm of the number in base b, which is in this form now. So you can see that in this case here is the power that is not given. So we can rewrite this because we have it as x is equal to logarithm 2, the number 16. So we can rewrite it in the other form, in indices form. If we want to write it, that is the number 16 is equal to, in base 2, to the power of x. So that is just simple as ABC. So in this case, our interest here is to see how we can rewrite this other side in terms of indices so that it will look like this one. How many times are we going to raise 2 so that we can have 16? If you look at it, it's also as simple as ABC. 2 times 2 times 2 times 2. 2 into 4 places will give us 16. So this you can also rewrite as 2 raised to power 4, which is equal to 2 raised to power x. So you can see that in this case the bases are now the same. So if they are off the job market, then you have 4 is equal to x. So in this case, our x is equal to 4. So you can see that even if the base is not given in the first case where we're able to determine what that base was, now even in the second case where the power was not given, we've been able to resolve that, and we can now see from the example that the power there is 4. So this missing item here is 4. And if you plug it in there, you can see that the expression will be correct. Like this other one, the third case. In the third case, that one is also as simple as ABCD. In that case, is the number that is not given. Is the number that is not given. We have 2 equal to the log in base 7 of the number x. And then we said we can also rewrite this as the number x is equal to the base raised to power 2. And if you resolve this, here we just have 49. So our x, the number that is not known, is just 49. X is equal to 49. So irrespective of the case, either the power or the base or the number, either of them, if they are not given, is also as simple as ABCD. And we can do business in determining what those various values are. Now the next thing I want to do is just to see, give us some laws of logarithms that will enable us so that having known them, anytime we see similar expression, we are just to invoke that this thing is this. If this is this, then we can rewrite it as this. Like as we have done in this case, anytime you see an expression of this form, A equal to B raised to power C, these indices, we can also write it in terms of logarithm as C is equal to the logarithm of the number A in base B. We can also rewrite it in this way. So let's consider some few cases. Now, also as we have similar to what we have done, given that x is equal to A and B. Now let me not go through this way. Let me not write it in this way. X is equal to A raised to power B, and say y is equal to A raised to power C. Now these two equations, we can rewrite this one in terms of logarithm. This one is in terms of indices. We can rewrite it in terms of logarithm. This we can write as the power, which is B, B is the logarithm of the number x in base A. Whereas this other one we can write as C is the logarithm of the number y in base A. Also this one in base A. So you can see that in this one we can also write it in terms of logarithm. Now in this one we can also write in terms of logarithm. Now what do we do? Let's try to multiply these two terms to see how the kingdom will look like. X, let's multiply these two terms, that is x times y. If we multiply this side, we are going to also multiply this other side. This implies we have a raised to power b times a raised to power c. A raised to power c. Now from our laws of indices, we have that when the bases are the same and the operator in between is multiplication, that we should take one of the base, which is a, then add the powers. This we have also learned. So we have b plus c, meaning that our expression is x times y is equal to a raised to power b plus c. Now, if you look at this expression here, you can now see that it's looking like this other expression where this term here is our x, a here is our a, which is the base. Now b here, we have it in terms of b plus c. So if that is true, then we can write this expression, which is in form of indices, in terms of logarithm. This we can write in terms of logarithm. Now if we want to rewrite this in terms of logarithm, as we have done there, meaning that we are saying this one, which is the power, is the logarithm of the number base in base this. So we have b plus c is the logarithm of the number x times y in base a. So you can see that we have rewritten this one in terms of logarithm. Now if that is true, this a, b and c, from this other expression, initial expression, we have b in terms of logarithm. We also have c in terms of logarithm. Now we want to convert it to logarithm because this other right hand side is in terms of logarithm. So let's also rewrite also this side in terms of logarithm. So in doing that, meaning we are going to change our b in terms of logarithm, write in b in terms of logarithm, also c in terms of logarithm. So in doing that, our b will be log of a of x, which is b, plus our c, which is this one. Our c is the log of a of y. We are done with this, all equal to the log of a x multiplying y. So if you see this, you can see that all the expression has been written in terms of logarithm. Now with this, we can just make a brief statement on that the log of the products is equal to the sum of their logs. That is, this we can also write as x, y, a is equal to the same thing. It's equal to ax plus log of a y. So we are saying that the log of the product of this is equal to the sum of their logs. This we can write a brief statement on this. Let me use another marker. This we can write as the log of the product is equal to the sum of the logs, is equal to the sum of the logs. The log of the products of this is equal to their sum. So whenever you have the log of the product of two entities, that you can rewrite it in terms of this, as we started from the beginning. So this is one law, and we should not forget this. Is very important as we move forward in our mathematical series, that the log of the product of this is equal to the sum of their logs. Now, today we have learned, in today's class we said it's logarithm, where previously we have learned indices, where we try to write a number in terms of the power of. And we are saying that those expressions that we do write in terms of indices, that we can also write them in terms of logarithm. We can write them in terms of logarithm. That one, the power, we are in terms of logarithm, we have it as the logarithm of that thing equal to the number which we have written in clear terms. Now we also try to see how we can determine, in case any of the terms are not known, either the power, the base, or the number itself are not known, how we can determine them, which we have also resolved, we have also seen. But lastly, what we did here was to see if we can come forth with some laws, binding laws, so that anytime we see expressions in a particular form, we know that we can rewrite it in another form. Like in this case, in the last case that we considered, we said the log of the product of this is equal to the sum of their logs. Now, in our next class, I'm going to consider other cases, other laws of logarithm, other cases, so that we will be able to get used to this as we go on with our mathematical series. Thank you for the sake of this class. As I will always advise you, try as much as you can to click on the subscription button. These lessons are for your edification. They are for you. Try as much, even if you are used to them, just keep watching them, just keep going through them. It will enable you to do more. Some things that may escape your memory, by the time you take a look at them, it will do you more good. So please don't just ignore them. Try as much as you can to click on them, watch the videos. Whenever you are having queries, don't also feel shy. Try to ask questions. You can inbox me, I will respond to you reasonably. But don't forget, always click on the subscription button, so that whenever we upload any video, you will be able to have a notification. Note that in clicking that subscription button, it won't cost you anything. Thank you and God bless you.